Hi, today we'll be discussing about evaluating limits algebraically. There are three methods of it: direct substitution, factoring, and conjugation, and I'll explain briefly so you can understand. The first one is direct substitution. This is the example: x is equals to 2. So 3x. So substitute the x into 2. So 3 times 2 is 6, and 5 is already given. 6 plus 5 is equals to 11. And direct substitution is that easy. Next is factoring. This is the example: x is equals to 3. This is kinda hard, but it's okay, I'll try to explain. X squared minus 9. How can we do this to cancel out? We factor it. How did we get this? So first, we'll multiply x with x minus 3. So x times x is equals squared. And then x times negative 3 is negative 9. That's how we factor. And now this is the answer. And then look, x minus 3 and x minus 3 in the denominator, we cancel that out. We only have x left. And then what is the x equals to 3. So the final answer is 3. Last one is conjugation. It is hard, so I'll try to explain it briefly. This is the example. Let's not include this yet. This one, the example. So we multiply it by the numerator, this one, as you can see. Since we cannot multiply them together yet, we put them together. So the square root of x plus 2, and multiply to itself is this. And then negative 3 and negative 3, it will become negative 3. That. So as you can see, it's negative 3. We make it the opposite, plus 3. So when we try to double them, it's like this. It's now the square root of x plus 2 squared and minus 3 squared. And in the denominator, we cannot multiply them together too, so it's like this: x minus 7 and the square root of x plus 2 plus 3. And this is what the answer is: x plus 2 minus 9 over x minus 7 and x plus 2 plus 3. We minus them together. 9 minus 2 is negative 7. As you can see, x minus 7. Oh, there's another x minus 7. We cancel that out. And this is what we're left off. This is what we're left off. This one. So we can now substitute it. X is equals to 7. So it's like this: 1 over the square root of 7 plus 2 plus 3. 7 plus 2 is 9, so it's become square root of 9. It's like this. And then the square root of 9 is 3. So 1 over 3 plus 3 is 1 over 6. And that is the final answer.
How to find a left and right limit? So first, to find the left-hand limit of a function limit extend to a minus f of x, you will first replace x with a minus h, where h is a small number greater than 0, and then you will replace extend to a minus with h. Tends to 0. This gives us the following image. And finally, you just have to simplify this and replace h with a 0 for the right-hand limits. The price is almost the same, except you will replace x with a plus h and x change to a plus with exchange to 0. As example, consider the following function: f of x. Then what is the left-hand limit of a function as x change to 1? So to find that, you will first replace x with the 1 minus h, and then exchange from 1 minus with h, change to 0. This gives us the following limits, and here 1 minus minus h will be less than 0. So therefore, you have to use the first variant of the function, and finally, by simplifying this and replacing h with 0, you will get the left-hand limit, h2.
Hello everyone, I'm Liz Marie Pimentera. In this video, I'm going to discuss how to evaluate the limits of transcendental functions, especially exponential, logarithmic, and trigonometric functions. First, exponential function. So these are the problem, and As you can see, we are given the limit as x approaches 0 of e raised to x. Since exponential functions are continuous, we can apply direct substitution. So, we substitute 0, 0 for x. This becomes e raised to 0. And we know that e raised to 0 is equal to 1. So, this one. Therefore, the limit of x approaches 0 of e raised to x is equal to 1. Now let's move on to the logarithmic function. A logarithmic function is the inverse of an exponential function. We are given the limit as x approaches 1 of natural logarithm of x. Logarithmic functions are also continuous within their domain, so we use the direct substitution. So, we replace x with 1. This one. This becomes natural logarithm of 1. And natural logarithm of 1 is equal to 0. Therefore, the limit as x approaches 1 of the natural logarithm of x is equal to 0. Lastly, a trigonometric function involves angles such as sine, cosine, and tangent. In this example, we will use sine. We are given here the limit as x approaches 0 of sine x. Trigonometric function like sine are continuous, so we apply again direct substitution. We substitute 0 for x. This becomes sine of 0. And sine of 0 is equal to 0. Therefore, the limit as x approaches 0 of sine x is equal to 0. And that's how evaluate limits of exponential, logarithmic, and trigonometric function using direct substitution.
Hey everyone, my name is Gianna Mia Altania and I will be discussing continuity on limits. First, let us know the difference between continuous and discontinuous functions. There are three conditions of continuous. 1. The function is defined at c, meaning f of c is a real number. Number 2, the limit of the function as x approaches c exists, denoted as. This means as x gets arbitrarily close to c, the values of f of x gets arbitrarily close to L. Number 3, the values of the function at c equals the limit. In the graph, there are no breaks, no jumps, and no infinite discontinuities. For discontinuous, there are three types: removal discontinuity, jump discontinuity, and infinite discontinuity. These are the forms of D and E. Now here, determine x equals 1. In graph A, we can see that there is a hole. Therefore, we can conclude that this is a discontinuous graph. In graph B, determine x equals 1. As you can see in the graph, there are no holes. There are no breaks. And you can also trace it with a pencil. There are no jumps and there are no holes. Therefore, we can conclude that this is a continuous graph.